Hey there, and welcome to the Into the Terminal, episode 44. Today we're going to be talking about different network configuration ideas around RHEL 9. Today we're going to try and talk a little bit about bonding, and I'm vamping while I remember to share out my screen. So let's dive into the terminal. Pun intended. All right, so first thing we want to do is looking at RHEL 9. There are some networking changes that we'll talk in the bottom half of the show, but let's walk through, for the top half of the show, let's walk through how to basically configure a network interface. So the command that we'll be working with the most today is nmcli, and to see what devices we have on our system, nmcli, helps if you type in the command correctly. So nmcli device shows us our list of devices. So that feels strange, but hey. So we've got our primary interface at ENP1S0, and then we've got a secondary interface at ENP7S0. You notice that one's disconnected. So for the sake of this lab and not breaking my connection, I'm going to go ahead and create an additional interface. And to do that, we're going to continue to use the nmcli command. We're going to use con, which is short for connection. We're going to give it a name. Let's be really clever here. How about Ethernet 1? And then the interface name is going to be ENP7S0. So we're going to use that disconnected interface for our new connection. And this is going to be type Ethernet. So we've got a new connection defined. So if we go back to nmcli device, we'll see that connection Ethernet 1 is now tied to device ENP7S0. By default, when you bring up a new connection, the connection defaults to a DHCP, and we can confirm that using a utility called nmstatecli. That's an additional package. It's an optional package that you can install, which I did before the episode started. So let's get some information on ENP7S0. So it gives us basically a dump of information from the Ethernet type, the status of the connection. If we go into the IPv4 settings, you'll see the DNS gateway and all that is set automatically. And we got an IP address already. and you notice, as I mentioned here, that DHCP is set to true. But let's give it a static address. So if we're pretty certain that our address isn't going to change, or perhaps you're in an environment that doesn't have or doesn't allow a DHCP server, we can set our addresses statically. So to do that, we're going to use nmcli connection modify because we want to modify our existing device, our existing connection. And to do that, autocomplete actually works very well with nmcli. So I just typed ETH and hit the tab key, and it's starting to autofill some of these things for me. So like if I do IPv4.addresses, because we're going to define a static IPv4 address, and we'll do something in the .122 range. So we've modified our connection. We'll have to restart that connection for everything to take effect. But let's do a couple more things. Let's go ahead and use the base of this command again. We're going to do connection modify Ethernet 1. Let's give it a let's set the subnet mask manually. And then let's also, just for grins here, why don't we set IPv4? Let's set the gateway. So those are kind of your main pieces of your networking connection, your IP address, your subnet mask, your gateway. We could get into DNS, but I had some problems with that when I was building the demonstration for today. So just for fun, we're going to go with that. Also, it's worth noticing that the first several groups of text here are identical, so we can actually merge all of these commands into one. So we could have given it our IP address, added a space, done IPv4 gateway, mentioned that, and then changed the method to manual. So we could have done all that in one command, but I wanted to break it out so we could kind of talk through it. So now we need to restart our connection. So we noticed it was already up. So you just do an nmcli con up and then our device, and it should be successfully added. So if we go back to our my terminal froze up. I think I just broke something. Oh, there we go. All right, it was just sleeping. It is Friday afternoon after all. So let's go back to nmstatecli. Let's do a show on IPv7, and then let's look at our IPv4 settings. So you notice IPv4 in the next several lines here. That's that -A10. So we've got a static IP address signed. DHCP is set to false. So now we've gone in and defined all that manually. And then if we look at routes, we can also see that I didn't specify the connection today, but you can see in here that we've now set our default gateway manually. So that's kind of the critical path of going and configuring a static network connection. We even added a new connection onto a physical port, virtual in this case. In the second half of the show, we'll be talking about what's changing in what has changed in RHEL 9, how that's going to affect RHEL 10. We'll also talk about bonding and bridges, and of course, that'll be the time to throw your questions in chat and get them answered live on air. So you may notice I'm flying solo today. Scott had a last-minute family situation come up, so it is just me, myself, and I today. So appreciate the patience as we kind of work our way through the conversation today. I'm the lab operator, the host, and the producer, so bear with me. This is Into the Terminal, episode 44, Bonding and Network Configuration. If you like this content, feel free to share it with a friend. We try and make it available to a wide range of audience, both the new to Linux, the new to IT, as well as the veterans. So keep sharing, keep liking and subscribing, because that helps us drive this content forward. So in this past spring, around May, we launched RHEL 9.0, which was a huge accomplishment, both for our engineering teams, for Red Hat as a company, and also for our partners and our community. It was a huge push to deliver on a promise of releasing a new major version every 3 years. And so there was some changes that came with RHEL 9. And back in April or so, we had an episode of RHEL Presents, I think it was, where we talked about some of the things you need to know before moving to RHEL 9. And so I just kind of wanted to take a moment real quick and mention some of those at sort of a high level in terms of networking. One of the first things is that network teaming is it has been deprecated in RHEL 9. So what that means is that a feature and a set of libraries are going away. They haven't gone away yet, but we are moving away from that. So out on the access.redhat.com site, we've actually got a knowledge base article on what's changing with teams, or what's changing with teaming, and how to go about finding a replacement. So first off, how to define deprecation. So deprecating means that it will not be included sometime in the future. Our goal is to have teaming removed by RHEL, excuse me, by RHEL 10. So in about 2.5 years from now, teaming will no longer be in future versions of Red Hat Enterprise Linux. So we expect that may change depending on depending on the availability of replacements. So basically, the resolution for teaming being deprecated and going away in a future release is that you'll want to use bonding instead, and we'll walk through an example of bonding here in just a few minutes. So that's a fairly easy resolution. Teaming was an earlier concept of networking where you can have multiple physical ports and a server tied into a switch, and they basically work, go figure, as a team. It would increase uptime, it would improve fault tolerance, but teaming isn't used nearly as much as it used to be. And instead, most systems are using bonding. And I see some chatter in the chat, so let me jump over to that. Let's see. So on the point of teaming, Shantanu asks, would we be covering create? Oh, okay. So yes, we'll be talking about creating VMs here in just a minute. In fact, I've got a web console system pulled up here in the background. And Iron Sysadmin, Mr. Nate himself, is hanging out in our chat today, and he points out that either nmcli or nm2i, which is a TUI, which is a terminal user interface, kind of one of those text-based menus, would allow you to create a bridge. So we'll get into that here in just a few minutes. Let's see. So that's teaming. So if you're building something new on RHEL 9, or if you have RHEL 8 boxes that you want to upgrade to RHEL 9, note that teaming will be going away. So if you start to plan for RHEL 10 or new projects, I'd highly encourage you to look at bonding instead of teaming. So enough on that. The next resource I wanted to point out, and there'll be links to all of these resources in the show notes. I normally don't go through the docs live on the air, but there is a ton of good information in here that I wanted to point out. We have documentation called Considerations for Moving to RHEL 9, and that has a list of some of the changes. So the first one here was networking teams are deprecated, and then we'll talk about a couple of these other changes here in a minute. But I just want to make you aware that in this Considerations in Adopting RHEL 9, there's an entire chapter dedicated to some of the networking changes. Now, one of the biggest networking changes, and we'll mention this and then get it back into the terminal here, is that as of RHEL 9, ifcfg files are dead, and long live key files. So what are key files? How are they different from ifcfg files? To get into that, let me switch back to my lab system here. Now, when this change was announced, I was a little unsure because I've worked on ifcfg files for 15 years or more, and so I was like, oh no, how am I going to retrain myself to do this? But since the RHEL 9 high touch beta dropped early this year, I've really liked working with key files, and I'll mention why here in just a minute. So let me scroll down here. Okay, so what we want to know about ifcfg files going away is that they have been replaced by key files. Now, while you may not be familiar with a key file, I bet you've probably seen them. So the new different distributions held their configuration files in different places. I think some of the Debian-based are like, actually, I just forgot off the top of my head. But things like CentOS, Fedora, RHEL, and other RHEL-like systems put them in etc sysconfig network-scripts, which was always a lot to type just to get to your network settings. Nowadays, they are in etc network manager. So if we move ourselves over to that directory, and once again, our VM is taking a nap. So is that, there we go. So in the network manager folder, we've got the main configuration file for that basically ties into nmcli is networkmanager.conf. So right now we don't have anything defined, but there's additional plugins that we can use. There's links to documentation, and you can make some changes here, like change where logging goes, what level of logging. So a lot of this is sort of the networking subsystem configuration itself. So there won't be much that you need to change to get up and running in the network manager.conf file. But where you'll probably spend the most time is in the system connections subdirectory here. So you notice Ethernet 1 that we created at the top of the show. So if we open that up, you notice that we've got it's an Ethernet connection. It's tied to ENP7S0, which was the interface. It's got a timestamp of when it was last, I believe that's last updated. Our IP address, our connection method, all of that exists here in the system connections subdirectory. And so this is a key file. So if you've worked with Ansible host files, if you've worked much with infrastructure as code, you've probably become more and more familiar with key files. So ifcfg-files were, in my humble opinion, were difficult to navigate through. There was the formatting was interesting. By interesting, I just mean different. But going to key files, I feel like this is going to be much easier. But those of us that are used to ifcfg just need to get used to the new layouts. Let's see. At the risk of breaking things live on air, I'm going to refresh my tab because it's really struggling here. While that's reloading, a lot of the demonstrations that we use exist in one form or another on lab.redhat.com. It is free to use and no registration required. You can actually go to lab.redhat.com and get access to over 20 different labs covering things from creating users to configuring network to working with containers. So lab.redhat.com. In fact, a lot of our critical paths are based on existing labs, so you can go out and try them for yourself. In fact, the lab I'm using today, I'll have linked in the show notes. So we can also use... So I will say that ifcfg files still exist in RHEL 9. That also will probably go away come RHEL 10. One of the things to keep in mind is that the reason for deprecating a feature is to give you time to retrain your muscle memory to use the new configurations. For instance, if you do an in-place upgrade, the ifcfg files will still exist. However, the system connections key files, like the one we just looked at, will take precedence over any ifcfg file. And using a cloud-based lab, I couldn't figure out an easy way to demonstrate that live on air without being almost certain that that I would break something. So just know that ifcfg files are still a part of RHEL 9, but we are defaulting to key files now instead. So there's a blog out there called Saying Goodbye to ifcfg files and Hello to Key Files that'll be in the show notes. Excuse me, I highly encourage you to go and check that out. Excuse me, it is a great blog. I think that's really all we want to mention as far as configuration files. So Shantanu actually asked a couple of weeks ago if we could talk about bonding and bridging. So I'm going to once again switch tabs here. We're kind of all over the place today, but wanted to cover a variety of topics. So bear with me for just a second. In fact, while I'm switching screens, now is a great time to throw your questions into chat. Nate and Shantanu have a lively conversation. So if you're catching us after the fact, I highly encourage you to join us every Friday at 12 p.m. Eastern, where we do this live on Twitch and YouTube. feel free to join us, put your questions into chat, and hang out with Scott and I. And sometimes Nate. Sometimes we let him come along. So, network bonding. Bonding is the process of taking multiple network ports and tying them together in order to use, in order to basically produce the best way I can think to explain it is to produce a bigger pipe. So by that, if you've got two 1 gig NICs and you bond them together, then you'd basically have one 2 gig. You would logically have basically one 2 gig pipe that's over two physical NIC cards. So that's bonding. Bridging, on the other hand, is the ability, especially in the virtual machine use case, bridging is actually designed to take a physical NIC and add additional network interfaces to that. Like I mentioned, we'll talk about virtual machines here. In fact, let me walk through that. So as you can see, I've been doing some cleanup. I usually have like 12 or 15 different virtual machines, and I'll mention why here in a minute. So I've got my RHEL 9 box here. This is just a RHEL 9 vanilla virtual machine that when I try and remember how to do something in RHEL 9 versus RHEL 8, I can just pop in here and try it out. So if we scroll down, we get all of our usage metrics. We get information about the BIOS, the virtual machine model. There we go. Maybe it's Chrome. I think Chrome may be slow today because even this tab's slow. Okay, so we're on network interfaces, and my RHEL 9 virtual machine has one NIC on it, and it is set up to use the VirtIO model. We can see the MAC address, the IP address, and you notice that the type is set to bridge, and obviously it's up because we've got an IP address here on my home network. Now there's two different ways that we can do virtual machine networking. The first is to add it to a physical bridge. The second is to two main ways, I'll say. There's a bunch of ways of doing this. In fact, you can another way is to assign a physical NIC to a virtual machine, so it's basically completely dedicated to that VM. Or you can actually set up a network within libvirt. Hey Benjamin, welcome to Into the Terminal. Glad you could join us live. So Benjamin, this is Benjamin's first time here. Sorry, Squirrel. So I had to say hi. So in my situation here, and I've got a hyperlink. Cockpit allows me to hyperlink to that bridge, but I want to go back into my physical nodes networking port or networking subsystem here, and notice that I've got an interface for Podman that we'll actually talk about next week, and then I've also got this bridge 0. And what bridge 0 does is I can add multiple NICs to I can add multiple physical NICs to this bridge and then assign virtual machines to use the bridge as their port. So you notice here that I've got a virtual network here, and then my primary NIC card here is this EMP4S0. That is a 10 gig fiber card. And then my EMP7S0 is actually a 2.5 gig Ethernet port that's built into the motherboard. So I actually never removed this when I upgraded the networking on this server. So we can go in and add members, and that will allow additional systems to utilize this bond. So that's bonded networking. In kind of a nutshell. It's fairly straightforward. You just basically, most of the time, bonding is used in a virtual machine environment to allow VMs to get an IP address on the actual physical network. So my RHEL 9 virtual machine and my ITG1 here, the name of my physical server have IPs on the same LAN. Whereas if we created a virtual machine network, they would have an internal network that all the virtual machines could talk to each other over, and they would have internal IP addresses and would have to go through a physical. Did I say bond? I meant bridge. Sorry, bridge. We'll get to bonding here next. So yeah, thank you, Nate. That's for bridging. So bonding here, I could actually create a new bond, and so I don't break my main system here, we'll take our virtual machine network and the inactive card, and I can actually bond them together. I can specify what MAC address they need to use, and then here's where bonding really comes into play. So if you've got big servers with multiple NIC cards, maybe you've got multiple fiber cards, you can actually determine how the different NICs will interact. So if let's say we've got two 10 gig fiber connect cards, and we've got a rack of servers, and they're all talking to a fiber switch that goes out to a router. We can actually what we can actually do is define how the network traffic is used. So you've got broadcast, which means it's going to send all the packets out, both of those NIC cards. You can do round robin, so that's kind of so it'll send this stream of packets out the first NIC. It'll send the second stream of packets out the second NIC. You can have a hot and cold. So if your main Ethernet port, maybe someone cut a cable or unplugged the wrong cable out of the switch, it'll actually switch to the second NIC. And then there's adaptive load balancing, which is a little bit more intuitive or more intelligent of an algorithm than just say round robin. So technically, we wouldn't want to use the virtual network. In this case, we'd want to use both the physical ports to go into my Ubiquity switch. So in the hopes of not breaking my my home lab, I'm not going to apply those changes, but hopefully that helps clarify the differences between bonding and bridges. Okay, so we are coming to the bottom of the show. And so to Shantanu's question a couple of weeks ago, what I wanted to kind of summarize in today's episode was that bonding, if you think about bonding as like interlocking arms with a friend to help climb a mountain, you all can work together to get to a destination, whereas a bridge is just like it sounds like. It takes something from one side across a bridge to the other side. So that's typically, like I said, most often when we see bridging as part of, we have a virtual network here. We've got multiple virtual machines that then get to send their network traffic over a physical bridge out to the internet. All right. And the Iron sysadmin here uses the analogy of a bridge over a river and getting your traffic from one side to the other, whereas a bond is kind of the same thing. So, or a bond also sounds just like what it's named to be. You glue two of them together, and then you define how you want the traffic to be. So it's a complicated topic. So definitely glad that Shantanu asked to bring this up so we could go in deeper to it. So next week, Scott McBrien should be back with me, and I'll have just gotten back from Ansible Fest. So if you'll be at Ansible Fest in Chicago next week, feel free to stop by the RHEL booth and come and say hello. Beyond that, I hinted at the Podman Containers tab. Next week, we're actually going to be looking at the next level of containers. We had an episode a few weeks ago, or a couple of months ago now, talking about containers and how to use them. this episode, we're actually going to look at one of the strengths of Podman, and that is using Podman pods. You can actually run multiple containers inside of a pod so that they can share resources, communicate back and forth. So we'll talk about deploying an application as part of a Podman pod. So meantime, feel free to check us out at Ansible Fest. RHEL Presents will be live on location, and then Into the Terminal will be live next week. Same place, same time. So thank you all so much for joining me, and we'll see you next time.